Integrals. One of the applications that we use integrals for is to find the area under the curve, like you can see here. And like you use it to find the shaded area between the point A and point B. The first type of integrals is the indefinite integral, and you can see you don't have a starting point, you don't have an end point, and at the end you need always to add plus c, where c is indicating any number. Now, the second type of integrals when you have a starting point and an end point like a and b, and we call it finite integral, and it is f of b, the answer, minus f of a. In this section, I will illustrate the basic rules of integral. We start with the integral of dx, or the integral of 1 dx, and the answer is x plus c. Now we go to the second rule, integral k dx, where k is any number, and the answer kx plus c. Take the following example. The integral of 3 dx will be 3x plus c. Okay, the integration of x to the power n will be always x to the power n plus 1 divided by n plus 1, and don't forget to add c. Now take the following example, the integration of x to the power 5 dx. The answer will be x to the power 6 divided by 6 plus c. Now the same example, we will go for integration of x to the power negative 4. And we will add 1 to the power. Thus it will be x to the power negative 4 plus 1 divided by negative 4 plus 1. And the answer will be x to the power negative 3 divided by negative 3 plus c. Now we will go to the trick of radicals, and keep in mind the power inside is always the upper number and the number outside is the lower part. Thus basically if you see the following integral, it is x to the power 2 divided by 7, then you will apply the power rule by adding 1 and dividing by 2 over 7 plus 1, and you simplify it further. Now the integration of k times x to the power n, and k will go out, and we will apply the power rule x to the power n plus 1 divided by n plus 1. Now you see the integration of 5x to the power 9, 5 will stay, and x to the power 10 divided by 10, and don't forget to add plus c because it's an indefinite integral. Okay, let's take another example. Okay, the integration of 3 times radical x squared with the index 5. This radical can be represented as x to the power 2 over 5. And now you will apply this rule. This it will be 3 times x to the power 2 over 5 plus 1 divided by 2 over 5 plus 1 plus c. And then you simplify it further. You can distribute the integration over the addition and subtraction operations. This, as you can see, integral of f plus g will be integration of f plus integration of g, and so with subtraction. Okay, find the integral of 4x squared minus 0.5x plus 1, and here we will distribute the integration over the 3 terms, as you can see. Thus it will be basically the integration 4x squared minus integration 0.5x plus the integration of 1 dx. Then we apply the rules as was illustrated before, just normal integration, and at the end you have to add plus c because this is an indefinite integration. Another example, find the integration of radical x plus 3x to the power 9 minus 2. Now the trick, radical x is basically x to the power 0.5. We will distribute the integration on the three terms as illustrated in front of you. Then we will apply the rule. Now the integration of radical x is basically the integration of x to the power 0.5. Thus the answer should be x to the power 0.5 divided by 0.5 plus 1. Now we move now to the integration of 3x to the power 9, and the answer is 3x to the power 10 divided by 10. And the integration of 2 dx is simply 2x, and we don't forget to add c at the end because we are dealing with indefinite integral. Well, there is no rule for multiplication in the integration world. Thus, first of all, when you have such a situation, you need to simplify by multiplying the two parts. Like we say, 3x times 2x will be 6x squared. 3x times negative 1 will be negative 3x. Then you will apply the integration as listed before. You will distribute, you will apply the basic rules, and then you will find the answer. At the end, don't forget to add plus c. In this example, we have the integration of x minus 4 times x plus 4, and you are dealing with conjugates. Thus take it as a tip. When you have a minus b times a plus b, it's going to be always a squared minus b squared. Now we will apply this rule, and when you apply it, you will end up having the integration of x squared minus 16. All what you have to do, you distribute the integration, and then you apply the basics rule of powers and constant in the integration word as listed before. Then don't forget to add plus c at the end. Another example, the integration of x squared minus 2 times x cubed plus x minus 1. We will simplify by multiplying using the arrows. Thus we say x squared times x3 will be x to the power 5, x squared times x will be x cubed, x squared times minus 1 will be negative x squared. Now we distribute negative 2 as well. Negative 2 times x cubed, negative 2x cubed, negative 2 times x, negative 2x, negative 2 times negative 1 plus 1. And then if there are like terms or like terms, we will add them together. Like I can see, like I have x cubed and negative 2x cubed, they are like terms. Thus if I simplify them, it will end up negative 1x cubed minus x squared minus 2x plus 2. Now I will distribute the integration, and I will do the integration of each part as following the basic rules that we did before. Of course, we don't forget to add a plus c at the end. Please follow the steps. The finite integrals. Find the integral from 2 to 4 x squared dx. First of all, the starting point is 2, the end point is 4. Now we integrate x squared according to the rules, and it will be x cubed divided by 3. Then we keep in mind that it will be substituting 4 minus the substitution of 2 as illustrated in front of you. Then you simplify to find the final answer. Another example, the integration from negative 1 to 5, 2x minus 1. We will integrate 2x minus 1, and it will be x squared minus x. We keep in mind that it will be from negative 1 to 5. Thus we have to replace the value of 5 in this bracket minus the value of negative 1 in this bracket, and you simplify it. You can do it as I'm just doing it in front of you. Just follow the steps, and it's easy. Another example, find the integration from 0 to 1 for the radical x squared with index 3. First of all, the trick here that this radical will be transferred into x to the power 2 over 3. This basically you are dealing with the integration from 0 to 1 for x to the power 2 over 3. You will apply the power rule by adding 1 and dividing by 2 plus 3 plus 1, and keep in mind to substitute from 0 to 1 and do the subtraction between them. Finding area under the curve. Find the area under the curve illustrated in front of you. In this function or this curve, we can predict that A actually is x equals 0 and B equal 4. This basically the area is the integration from 0 to 4 for x squared plus 2. Now you will integrate, the answer will be x cubed divided by 3 plus 2x, but we don't forget that we have to deal from 0 to 4. This basically you will substitute with the 4 value minus the substitution with the 0 value. You find the answer that the answer will be the area. Another example, find the area bounded by x-axis, x equals 0, x equal 1, and f of x equal x cubed. Obviously that we are dealing with the integration of f of x dx. And when he says x equals 0, this is A, and x equal 1, this is B. This basically you're dealing with the integration from 0 to 1 for x cubed dx. The answer will be x to the power 4 divided by 4, ranging from 0 to 1. When you substitute, the final answer will be 1 over 4. To find the area between two curves, we will keep in mind that the upper curve, we will call it up, the lower part we will call it down. The area is basically the integration from A to B, up minus down. In this case, from A to B, the integration of f of x minus g of x. Find the integration from 0 to 1 for the shaded area, and you can see the reddish curve is the upper one and the bluish one is the down or the lower curve. Thus we will say the integration from 0 to 1 up minus down, thus it is the integration from 0 to 1 for 2x minus x squared in a bracket minus x squared. Then you will simplify this expression. You will apply then the basic rules of integration. Don't forget to substitute 1 and 0 and do the subtraction, and then you will find the final answer of area. Just please follow the steps illustrated in front of you. Another example, find the area enclosed by f of x and g of x. From the graph, you can predict that f is the upper part or the upper curve and g is the lower curve. And the integration is from -2 to 0 for f minus g. Now we replace the value of x cubed minus 6x plus 3, which represent f, minus x squared plus 3. Be careful when you simplify, and keep again in mind that the area is the integration from -2 to 0 for the simplified version of the subtraction that's happening now. Keep in mind you have to replace also the values of 0 and -2 and do minus between them to find the final answer. This is the end of the lesson. Thank you for watching.